Hello, I've had a question in the calculus course, Unit 2, Lesson 4, questions 11, C, and D. So for each of the following, find the distance between the point Q, 3, -2, to each line. So in order to determine distance between a line, all right, so I think I use capital D as my notation, you need the magnitude of the ax plus by plus 2d plus c divided by square root of a squared plus b squared. So that means we need to get these equations in standard form. All right, so for 11c, we know that our direction vector is 1/5, 1/6. So again, the normal dot the direction vector is going to equal 0. So we want to pick values AB dot 1/5 and 1/6 that equal 0. So I'm going to get rid of my fractions because I don't want to use fractions moving forward. So I'm going to say -6/5 dot 1/5, 1/6 equals 0. So that'd be -6/5. Nope, that wouldn't work. Good job with the math there, Mr. Aga. Let's try that one more time. Let's go with negative. I guess I'll just keep it simple. I'm going to go -1/6, 1/5. So that would give me -1/30 plus 1/30. So therefore, my normal is -1/6, 1/5. I really don't want to deal with fractions. Let's multiply through by 30. So we'd end up with -30/6, so -5 and 6. So there's our normal. Need to get it in standard form. So we take our reference point, because into standard is normal dot p equals 0. So -5, 6 dot, I just need to see the point, so it would be x plus 3 and y plus 7 equals 0. So moving that through, we end up with -5x minus 15 plus 6y plus 42 equals 0. So -5x plus 6y, and we end up with 27. Be positive. So there we go. So finishing this one off then, our magnitude is the ax plus by plus c divided by a squared plus b squared. So we have -5. And from above, we're using the 0.3, that was what was given, plus 6 times, I think it was -2, plus 27, divided by -5 squared plus 6 squared. So on top we have, what do we have, -15 minus 12 plus 27. So I get 0 over, well, isn't that nice? I don't care what it's over, that's 0. So guess what? That point is on the line. So Q is on the line. Guess I should have checked on the very first step, but I did not. So there we go. That's the process. So it must have meant originally that that point falls on that line. So if we would have multiplied through, and we would have, if we would have done the check, I guess we would have found out that right away. So anyway, a little bit frustrating. So anyway, let's try D. So this one's definitely not on the line. So we need to know, we have our equation. Again, it's in standard form. So if we rewrite it, we have x plus 5 equals 0. So that means that my normal is 1x, 0y. So my direction vector will be 0, -1. All right, or it could have been 0, 1 as well would work. So that means that, actually, it's already in standard form. I don't know what I'm doing. Well, I know what I'm doing, just not paying attention. It's already in standard form. So D equals AX plus BY plus C over the square root of A squared plus B squared. So we already have the form we want. We want standard form. So that means we would have the X value. So we're looking at the point 3, negative 2. So technically A is 1 times 3 plus negative 2, but the Y, and B is 0 plus 5 divided by the square root of 1 squared plus 0 squared. So we end up with 3 plus 5 is 8 over 1, so it's 8 units. So therefore, the point is 8 units from the line. All right. If you have any questions with that, let me know and tell me specifically what the issue is, and I'll see what I can do to help you out. Again, I guess I should have checked that first one, see to find out if it was on the line to save me a lot of work. But regardless, it does show you the overall process if it is not. All right, let me know.